Hey guys, it turns out that I'm going to miss class today because we're going to be working on some math textbook stuff this afternoon. And so you're going to finish up today with watching a review of yesterday's equation solving, working on your equations and getting the worksheet done, A5.5. And then I want you all to go over A5.4 together. The minute we walk in tomorrow, we'll go ahead and do the homework check over 5.1 through 5.4. We'll delay the quiz over properties and equation solving until Friday, after I know you've had a good chance to ask some more questions tomorrow. All right, so let's get started. All right, yesterday, and if you want to go ahead and title your notes, you can, or just put a subtitle on your notes that today we're doing mixed review. So yesterday's notes were entitled Solving Exponential and Logarithmic Equations, but we did things in categories. Today we're going to do mixed review so you get better at categorizing the type of equation before you get started. So remember, there are a total of 4 types of equations. You can solve exponential equations in 2 different ways, and you're always rewriting. So you either write the equation as powers of the same small base. That's type 1, b to the this equals b to the that. Those are a little easier. Or if you realize that that's not doable, you rewrite in log form. Note, you always change forms. If you start with exponential form, you change to log form. If you start with log form, you change to exponential form. So there are also 2 types of logarithmic equations. If you have logs only on both sides of the equation, you condense to a single log on both sides of the equation and write it log of this equals log of that. This is a little easier. If you determine that's not doable, then you go, okay, so this is a log equation that I've got to convert to exponential form. Now, let's work some examples. Take a moment, write down this first equation. So when we look at this equation, the first question is this an exponential equation or is this a logarithmic equation? Well, this one I noticed has x's in the exponent, so that makes it an exponential equation. I can also tell there's no L in the equation. It can't possibly be a log equation. So now my next natural question is can I write it b to the this equals b to the that? That's always my first go-to. But the answer is no, because E is the base, and there's no way you can write E as some normal number as a power of E. So let me go one step further. I always have to isolate the exponential or the logarithmic portion. So I need the e to the 3x by itself. So what do I do with the 1/2? Multiply both sides by 2. So the 2's cancel, and you'd be left with e to the 3x equals 20 times 2, 40. So what I was just saying is e and 40 are not powers of the same small base. Nothing is going to be a power of E other than E. Like if you had e to the 3x equals e to the 5th, or e to the 3x equals square root of e, then you could do b to the this equals b to the that, but not when it's e and a normal number. So that means it's not a b to the this equals b to the that problem. So that means the other option is rewrite in log format. So rewrite in logs. So I know I've got to do, here, I'll do this in black so it stands out better. I know I've got to do this in log format, and the base of the exponential is e, so the base of the logarithm is e. I've got to say, don't plug in 3x and get 40. Instead, plug in 40 and get 3x. Now, the only thing you need to do to isolate x is divide by 3. Well, I'm also going to remember log base e of 40 is not the way you use it. You leave it. So I make it ln 40 over 3. So x equals ln 40 divided by 3. I'd give credit for that. That is not as typical, though, as writing 1/3 ln 40. That's the more normal way you would expect to see it, like on the ACT. Remember, someone on the ACT might even write that as ln cube root 40. All right. Problem 2. Take a moment, write that down. So I'm going to start with the same question. Is this equation exponential or logarithm? Well, I mean, I see a log in it, so that automatically makes it a logarithmic equation. So that's out. Now, I'll tell you that the first thing you need to do is isolate the log. So that means I need to divide out that 40. So my first move is log base 2 of x equals 7 divided by the 14 is a half. Okay. Now, on log equations, I'm wondering, can I write it as log base 2 of this equals log base 2 of that? Well, that really requires you to have a log on this side and logs on that side, and that's all you've got. That's not really the situation here. So you're going, no, it's not really one of those. Instead, you're going to say, all right, it's not this kind of rewrite. So the rewrite that it is exponential form. So go to exponential format. All right. So y'all are good at this one, right? This is the easier way. So I'm going to say 2 to the 1/2 power equals x. How do we write that normally? Oh yeah, x equals square root 2. Now remember, with logs, you've got to be careful because you can't have an x value that when you plug back in, it causes you to do the log of 0 or the log of a negative. Because remember, you can only take logs of positive. But log of square root 2 is positive. So log of square root 2 is doable. It's a good answer. Leave it. Example 3. Go ahead and copy it. And we're going to start with the same question. Is this a log equation or an exponential equation? I see lots of logs. It's a log equation, not an exponential equation. Now, on this one, I'm also asking myself, is there a way to write this one as log of this equals log of that? Guys, since I have nothing but logs on the left and nothing but logs on the right, I can write it as log of this equals log of that. So yes, this is my strategy. So what I need to do is condense, because you can only have one log on either side of the equation. So on the left side, I need to write it as log base 4 of, ditto on the right side. So on the left side, the property of logs is if you have 2 logs subtracted, the related operations division. So I say 2 over x minus 1. Similar thing on the right side. So I'm going to say 3 over 9. Yay. So now I have a log of this equals log of that. My next natural move is to say, oh, so this equals that. Or if you want to make it even easier, I should have done this already, 3/9. I could reduce to 1/3, and that would make my cross multiplying a little simpler. So cross multiply, so 1 times x minus 1 equals 2 times 3, x equals 7. So 7's fine, because if I say log base 4 of 7 minus 1, that's log base 4 of 6, that's fine. And that's the only one I needed to check. So 7's a good answer. Leave it. Problem 4. So is this an exponential equation or a logarithmic equation? Again, I clearly see logs in the problem. So it's a log equation, not an exponential equation. So I'm asking myself, so can I make it log of this equals log of that? Well, I can make it log of this, but I can't make it log of that. Because look, the left side has 2 logs And I always want to simplify down to 1 log. Well, how do I simplify this to log base 2 of? Oh, so remember what I'm supposed to do if I've got logs added, I condense via multiplication. So I really need to do x minus 3, x minus 5, and multiply that out. So the left side is going to be log base 2 of x squared when I FOIL, minus 5x minus 3x would be minus 8x plus 15. But look, the right side isn't a log. It's a number. So no, it's not a log of this equals a log of that. It's not that because I don't have logs on both sides. So this is instead take your log equation into the opposite format, the inverse format, which is exponential form. So I'm going to say 2 to the third equals x squared minus 8x plus 15. All right, I know that's 8. If it's a quadratic equation, pull everything to one side, 0 on the other. So I'm going to say x squared minus 8x, and it'll be this 15, subtract over that 8. 15 minus 8, 7, positive. Do I need to do quadratic formula or complete the square, or will it factor? So if in your head you're saying it'll factor, you're right. Go AC method. So let's see, I need to do 7 times 1. So it's going to have to be minus 7 times minus 1 to add up to minus 8. X equals 7, X equals 1. Now let me check to make sure that those plug back in okay. You don't have to check on exponential equations, but log equations you do, because the domains of logarithms are limited to only positive input values. The domains on exponentials are not limited. You can use any kind of number for an exponent. So plug in 7. 7 minus 3 is 4. That's positive. 7 minus 5 is 2. That's positive. You're okay with 7. So 7's a good answer. Check 1. 1 minus 3 is negative 2. I can't do log base 2 of negative 2. I can't do logs of negatives. So 1 is a bad answer. Strike it. It's extraneous. Question 5. All right. So on this equation, is it exponential? I'm trying to drag this a minute so you can get this copied. Or is it logarithmic? So I see x's in the exponents. That is an exponential equation. It's not a log equation because I see no L. So not no L as in Christmas, no capital L or no lowercase l in the equation. So it is not logarithmic. So my immediate question is, could I make it some small base to the this power equals some small base to the that power? That's what I'm asking first. So look at your base of 3 and your base of 27. Yes, they're both powers of 3. So yeah, this is a b to the this equals b to the that problem. So 3 and 27 are both powers of 3. So 3 to the 4x minus 1 is already in good form. 27, remember, is 3 to the third power to the x. So I've almost got it in b to the this equals b to the that form. Remember, power to a power, multiply. Now I've got it in 3 to the this equals 3 to the that form. I've achieved the form. So this is easier because now you don't need to do logs or anything. You just say, okay, so this left exponent equals that right exponent. Subtract x, which is subtract 3x to get 1x, add the 1, x equals 1. So you can plug 1 back in and just check that it works, but you don't need to check for extraneous. The only solution or equations that have extraneous solutions could possibly be log equations. Exponential equations never will. So if this number doesn't plug back in right, it just means you made a mistake, not that it's extraneous. So if I plug back in, if I did want to check just to see if I was right, then I would say 3 to the 4 times 1 is 4, minus 1 is 3, and 27 to the 1 power. So 27 equals 27, it checks. So that tells you x equals 1 was the correct solution. Next equation. Okay, so on this one, is it exponential or logarithmic? Hopefully you're going, Sporter, that's kind of obvious. There's a log in the equation. So it is an exponential equation. Is it a log of this equals a log of that problem? I don't think so. I don't know for sure. I need to do the first step, but I don't think so. So first step is I don't even have the log by itself. So I need to isolate that. I do so by dividing by 6. So I'm going to say log base 25 of 8x equals 3 divided by 6, which reduces to 1/2. Now, is it a log of this equals log of that problem? No, I've got log of this, but that is not log of that. That's a number. So no, it's not this. So that means you got to change format. You got to rewrite it in the inverse format. So that means go to exponential form. Rewrite in exponential form. So exponential form is 25 to the 1/2 power equals 8x. No, wait a minute. 25 to the 1/2. Oh yeah. Square root 25 equals 8x. Square root 25 is 5 equals 8x. Cool. X equals 5/8. Is 5/8 an okay answer? It's a log equation you got to check. So when I say what is 8 times 5/8, it's 5. And yes, log base 25 of 5 is safe. That's a positive input value. You're good. So 5/8 is a good answer. Next problem. Okay, log base 5 of log base 3 of x is 0. There's no doubt it's a log equation. Forget this. Now, is it a log of this equals a log of that? No, because there's no log over here. So that means I've got to go to exponential form. So I'm still flowing through the same series of ideas. I'm just not writing quite so much. So if I need to go to exponential form, here's something that might help you. Condense this or rewrite it for a moment. This might help you to see. Let the log base 3 of x on the inside, let's use a dummy letter to stand in for that. So let me say log base 5 of some dummy letter equals 0. That might make it easier for you to see the phases of the problem. So rewrite it in exponential form. So 5 to the 0 equals d. Let me reverse sides of the equation. So d equals 5 to the 0, which is 1. Now, what did d stand in for temporarily? Log base 3 of x. So go back to that. Now, you've got your second logarithmic equation, rewrite in exponential form again. So 3 to the first equals x. X equals 3 to the first is 3. And sure enough, if you go back here, log base 3 of 3 is safe. Log base 3 of 3 is 1. And then log base 5 of 1 really is 0. So it's not only safe, but I checked it real quick. All right, 2 more examples. All right, here we have got an equation, 2 to the x equals 1/64. Is it exponential or logarithmic? I don't see an L. It's not logarithmic. Boom. Is it exponential? Yeah, because there's an x in the exponent. So yes on this. So can I write it as b to the this equals b to the that? So always divert. If you've got a list of your types of equations, make sure you go methodically. Is it exponential? If so, is it this type? If not, switch to the other type. Is it logarithmic? If so, start with log of this equals log of that. If that didn't work, switch to the other type. All right, so on this one, I say, yes, this is the way to go because the base of the left side's 2. The base of the right side, look at that 64. I can make that a power of 2. So if I write it as 2 to the this equals 1 over 2 to the that. 64 is 2 to the 6th. So 2 to what exponent will make it drop to 1 over 2 to the 6th? It would have to be, guys, 2 to the negative 6, which equals 1 over 2 to the 6th. That's what I'm thinking. So that means this x is that negative 6. I don't need to check answers for extraneous because exponential equations don't have extraneous solutions. All right, one last one. Okay, problem number 9. Is it exponential or is it logarithmic? Okay, I see no L's. It's not logarithmic. Furthermore, there is an x in an exponent. It's an exponential equation. So is it a b to the this equals a b to the that? All right, I can't tell yet. Here's why. I don't have the exponential piece of the equation isolated. I need to isolate that first. So what do? Add the 5 to the other side. So I'm going to say 4 times the exponential piece equals 27 plus 5, which is 32. I still need the 10 to the 3x minus 12 to be by itself. So divide by the 4. So 10 to the 3x minus 12 equals 8. Now decide, is it a b to the this equals b to the that? You can't really tell till you get it into the exponential equals one thing on this side. You can't really tell. If it was 10 to the 3x minus 12 equals 100 or something like that, it would be a 10 to the this equals 10 to the that. But 10 and 8 are not powers of the same little base. So no, it's not a b to the this equals b to the that. So that means your other option with exponentials is rewrite in log form. Go to the inverse form. So go to log form. All right. So if it's exponential, go to log form. If it's logarithmic, go to exponential form. Go to the inverted form. All right. So the inverted form is a log. The log base 10, the base of the exponential, of the opposite side equals the input originally. So remember, what was the output becomes the input. What was the input becomes the output. All right, so I don't expect you to know that log base 10 of 8. I don't expect you to know what decimal it is, but I do expect you to realize that's just a decimal. So I've got to isolate 3x and then isolate 1x. So to isolate 3x, I add 12 over. Now, if you want to drop the base 10, you can. All right. So let me remind you that the more normal order is to put the plain number ahead of the log number. So I tell you what, since I'm having to rewrite, I'll say log of 8 because I'm allowed to say log of 8 instead of log base 10 of 8. That's a choice though. You can keep the base 10. Now to get 1x by itself, divide by 3. So separate it, that's 12 over 3 plus, now I'm going to write this as log 8 over 3 or 1 over 3 log 8. That's more common. So that's going to give me 4 plus, and I would probably leave it 1/3 log of 8. But remember, you could make that log of cube root. Oh, cube root of 8. That's 2. Oh, that's cool. That's nice that that shrunk. So do I need to check that one? No, because remember, exponential equations accept all input values, so no extraneous solutions. All right, I want you to get in your assigned groups of 4. If someone's missing and you can only form a group of 3 today or a group of 2, if a couple of people are missing, that's fine. But move together and help each other do a 5.5. And then I'll fill lots of questions with you tomorrow. All right, if you are really in need of some extra help, swing by my classroom after school today. I'll be back in here at 3:45 if you really want some help on the spot. All right, good luck. Have a good one, finish a 5.5, and then help each other finish and or check 5.4. So you're ready for tomorrow's homework check.